So this is where we got to in the last lesson. Now I don't know about you, but this feels like we're expanding our code quite greatly to a point where we kind of need to break things down into functions and modules. So what we're going to do in this lesson is learn how to move things across into their own files and essentially refactor our local storage to create a nice web storage module that handles not only local storage, but optionally session storage. Now underneath our src, what I'm going to do is create storage.js. So this is going to be a new module that's then going to be a constant called storage. Now this is going to export a function and then return us the behavior for our module. Now depending on what type of storage we're going to have, we might want to ask for local storage and we might want to ask for session storage. So what we're going to do is essentially move our set value, get value, remove item, and empty across to this returned object. So let's go ahead and return the object and then we can start moving things across. So this is almost a module pattern where in traditional JavaScript we would encapsulate some logic such as an object inside of a function. However, with the invention of JavaScript modules such as import and export, we can make this pattern a lot cleaner and encapsulate our logic in a single function. So if we go ahead and grab our code, what I'll do is just uncomment these. And we're going to take our empty, remove item, get value, set value, and this local storage definition, copy it and simply delete it. So this file is essentially just going to be integrating with our UI. You can see that there's no longer, apart from our set value calls, there's no longer any local storage definitions. So what we can do is jump into our function and just paste in our existing code. Now you may be wondering, what is this type? Now what I'm going to do, because we can use string interpolation, I'm going to pass in the word local or session, and then we're going to return the functionality depending on what the user actually wants. So if we jump into our index, what we can do first is import this storage object. So because it's a constant, we're going to import our storage from the current directory /storage. Now, if we hover over this, we'll see our type definitions. You can see that it accepts a type of type any. We're not using TypeScript. However, I would recommend that we perhaps look into using a type system so that we can ensure that our storage is being handled correctly. So this new API gives us the ability to do something like this. We can say, I want local storage. So I'm going to ask for the local storage. And if we were to ask for session storage, and I'm going to abbreviate this as SS for session storage and LS for local storage, we can then say that I want session storage. So this is the API for our utility function. If we then say console.log ls, we can then log out our SS as well underneath. So this is our two APIs. We'll then integrate them where necessary and replace our existing set value functions. Now we're doing this because our first set value function, our accept, is going to add it to our local storage, and our reject is going to add it to a session storage. And this will make more sense as we continue, and you'll see why this ties in with the UI. So if we jump into our storage, what we want to do is essentially start returning some of these functions. Now, because this is part of a module, we can turn these into object methods. So where we have our set value, I'm going to take this and just simply copy it and delete it. So we're going to return a set value. Now, because this is a method, we can use a shorthand method declaration such as set value. Now, I don't want to keep set value. I'm just going to change this over to set. So we can have storage.set as our API, which I think is quite nice and clean. We can then add our get. So this is going to be get instead of get value. We can refactor this over to a shorthand method expression as well. Copy this and go ahead and delete it. Add it to our object. And you can see that things are neatening up nicely. We then have our empty. So we can go ahead, copy that and delete it away. Add it to our object definition and refactor it over to a method. Similarly, with our remove item, we can go ahead and clean things up even further. Now, because this is an object, we do need to comma separate these, so don't forget to do that. And we should have an API that ends up with something like this. And I think you can agree that this is a nice way to do things. Instead of having lots of different functions, we just have one API, this storage block, which then has all of these particular methods, such as setting and getting, removing, and then emptying the entire storage. Now, at the moment, we're not using this type, so we're using this local storage exclusively. So how could we cleverly use our type? We could say somewhere in here, if type equals local, then return the local storage, or if the type equals session, then return the session storage. However, what I'm going to do is assume that we're going to be a bit more clever than that. So what we're going to say is square brackets, so this will help us look up a property on the window object. We can then simply interpolate our type and then add the word storage afterwards. So this is essentially going to add session storage or local storage to the window object. It's then going to return us our particular storage. Now, instead of keeping our constant as ls, I'm going to then change this over to store. So the store is whatever kind of storage we'd like. It's going to be the window local storage, or it's going to be the session storage. And because functions in JavaScript create new scope, this is going to return us a new object every single time we call it. So when we invoke local here and then session here, we're going to get two independent objects with all the methods that we need. So if we were to hit dot, for example, you can see that we have set, remove, get, and empty. So our API is working as we'd intend it to. Now, at the beginning, I mentioned to you that we had this feature detection to check whether something is in fact supported. So what we're going to say is a new property called isSupported. Now, this is just going to be bound to our object, which will then allow us to conditionally check whether the browser that we're using has support. So we're going to say const isSupported equals, and do you remember we used this type of storage equals function. We could, of course, say store.constructor equals storage as well. I quite like this approach as it doesn't really tie in with either session or local because they're essentially the same API. So what we'll do is save out our storage module. I think this is really nice. We've got this isSupported. This is going to then return us a Boolean value. So in our code, we can then say, if local storage is supported, go ahead and use it. Which means what we can do is jump into our set value and change these across to local storage dot set cookies of true. And instead of local storage on this one's going to be session storage. So what we're going to do in our application panel is completely wipe our local storage. Session storage has nothing in it, so that's absolutely fine. We can hit save. Our page refreshes. Our cookie banner is going to show itself. We can then say no. You can see that our local storage has nothing in it. Our session storage, however, has cookies false. Now, I haven't actually demonstrated how this session storage is working. So what I'm going to do is create a new tab and close the existing one, and then load in the same page. We can jump into our application tab, and you can see that session storage is now completely empty. So if the user says no, it then remembers it for the duration of that session. If we were to say yes, we can obviously jump into our local storage, and you can see that cookies is then true. So if we were to close the tab and open a new one, we then get asked again because we're not tying in any events yet, but you can see that local storage is now persisting. So it's going to permanently remember our choice if we accept, and temporarily remember using session storage when we decide to reject. So if we jump into our isSupported property, what we're going to do is just quickly hook this into our functions. Now, at the moment, we've got const cookie, we've got our functions, we've got our set timeouts, and they're all kind of just floating in this module, in this index.js file. Now, what I like to do is create some kind of init function, which we can then call feature dependent. So what we can say is if local storage is supported and session storage is supported, then we want to actually init our application. Because otherwise, we don't want to then show the cookie banner because there's no way of hiding it, for example. It might also be that the user has JavaScript disabled. So now what we want to do is take our existing code and just simply move it up into this init function. So what this is going to do is essentially safety check against our feature. So if local storage and session supported in the browser, then we want to boot off our module. And this is a good safety practice that we can make for our code base. There's one final thing that we need to do inside of our init, and that's handle a few different checks. So what I'm going to say is if there is no cookie, which means that the DOM node doesn't exist, then we want to simply return. It might be that we're not showing this particular node on a specific page. So we don't want our JavaScript to execute and then throw an error. Now, there's one more thing that we want to do with this set timeout, and I'm going to move this down the bottom because what we're going to do is jump out of our function if a few conditions are met. So if the cookie DOM node doesn't exist, then we want to just simply return. We don't want to call our show because it's going to throw an error because the DOM node doesn't exist. Now, the other condition is if our local storage module has this true value, which we do at the moment. We don't want to keep showing the banner if it's true, so we can say local storage.get, and you can see that we have this key of any. So here we're just going to pass in cookies. So if we jump into here just to refresh, we have this get, which is then going to JSON parse our returned get item. So if the user has already accepted, we're just simply going to return. The cookie banner will stay invisible underneath the scenes, but it's not going to be shown to the user. The other condition is that if the user has selected no, we then put this into our session storage. So we want to, in fact, check this as well. Now, there's one interesting thing because we don't want to use an inverted expression because it might be that we say session storage.get and we want to get the cookies. Now, because this value is actually false, we don't want to do something like this because it's always going to be true if the value does not exist. So we want to just simply explicitly check whether the user has selected false, which means when we save this out, what I'll do is just clear out our session and our local storage and refresh the page. So you can see that we have, would you like a cookie? I'm going to say no. I can refresh. Now this is going to be stored in our session storage, and you can see that the cookie banner is no longer being presented to me. However, if we clear this out, hit refresh again, we can jump into our local storage. We can say yes, it's then added. We can hit refresh again, and it's not going to ask us if we want to accept them. So we have the full behavior that we'd expect. If we click yes, it's saving it in local storage. If we click no, it's saving it in session storage. So that completes the UI aspect. What we're going to do in the next few videos is look at things like error handling, getting all the local storage values, and also this nice on-change event, which is quite a nice addition to the spec. So I hope you like this video. It's been fun rewriting this and changing it across into its own little module. It's quite a concise and neat API. We can then import it and start using it accordingly. So that is it for this lesson. We've created our storage of local, storage of session. Of course, you could make this a bit more bulletproof and check the actual strings because it doesn't prevent people making typos, for example. But we've successfully integrated a proper Boolean primitive value in JavaScript with local storage and session storage. And of course, if you want, you can use arrays, JavaScript objects, anything you like to then store in our key value mini database that essentially is local storage.